This LOS is calculate and interpret covariance given a joint probability function. Okay, the first thing that we're going to do is we're going to look at the expected value using the probability model. Now, we looked at the expected return before, which was just the weighted average of the expected returns. But now we're going to look at a expected return based on some probabilities. So here we have the industry. There's three possible outcomes for the industry. The forecast could be good, it could be average, or it could be poor. And so the probability of a good outcome for the industry, 20%, average 50%, and poor 30%. If you add those all up, we're going to get to our 100%, of course, okay? All possible outcomes. So if the industry is good, we're going to have the expected return is 25%. If it's average, it's 12%, and if it's poor, it's 10%. So how do we calculate the expected return using a probability? We just take that probability times the return. 20% times 25 equals 5%. 50% times 12% is 6%. And 30% times 10% is 3%. Don't even need my calculator. We add them all up and we get 14%. Okay? So then how do we calculate the variance or the standard deviation? Well, we can see here columns 1, 2, and 3 is just the same as the table above, okay? And we have here our expected return is 14. So if we look here in this column, we have to do our return, which is 25%, minus our expected return, which is 14%, and we're going to get 9%, okay? 12% minus 14%, negative 2%. 10% minus 14% is negative 4%. So we do return minus expected return. Then we do return minus expected return. We square it. So 9 times 9, 81. Negative 2 times negative 2 is 4. And negative 4 times negative 4 is 16. And then finally, this is the last step. I put some numbers on the columns. We need to multiply the probability, column 1, times return minus expected return squared. So 0.2 times 81 is 16.2. 0.5 times 4 is 2, obviously. And 0.3 times 16 is 4.8. We add that all up together and we'll get a variance of 23, square root of the variance, 4.79. So this slide was looking at the expected value or expected return based on a probability model. And then we took that a little bit further and we calculated the variance and standard deviation based on a probability model. Now I put this slide in just for a little bit of fun as an FYI. It's exactly the same as the previous slide, but instead of using whole numbers, I used decimals. Okay, and you can see that's why the key is if you stick to everything to decimals, you really need to be running 5 decimals in your calculator. So as I said, on some questions they give you decimals, on some questions they give you whole numbers, in some questions they give you a combination of decimals and whole numbers. What you want to do is pick one method that you always use and stick to it. So this slide was just a little bit of fun. It's the exact same numbers as the previous slide, but everything's been presented to you in decimals, not in whole numbers. So here's a practice problem. The table below provides a probability distribution of stock returns for shares of Orion Corporation. So the probability, 15% probability, return of negative 12%, 60% probability of a return of 11%, and a 25% probability of a return of 18%. The variance of returns for Orion Corporation stock is closest to A, 44.36, B, 50.94, or C, 88.71. So the correct answer is C, and we're just going to work our way through it. So again, we had to create a table similar to what I did previously. So again, we start with the same information that is given to us in the question. Probability 15% times the 12% rate of return, you're going to get 1.8. 0.6 times 11 is going to give us 6.6. 0.25 times 18 is 4.5. And this is the important part. You have to sum all that up, and you're going to get 9.3, and that's the expected return. If the question asked you for the expected return based on a probability function, that would be easy. We're at 9.3%. But we're not done yet. The question is asking for the variance of returns. So again, we're going to do the return minus the expected return. So there's our return, 12%. We're going to do negative 12 minus 9.3, and that's going to give us negative 21.3, correct? Which I've written here. 11 minus 9.3, expected return is give us 1.7. And then 18 minus 9.3, and that's going to give us 8.7, okay? Then return minus expected return, we square those numbers for this column. And then, remember, we had to take that probability, column number 1 times column number 5. And so we've got the probability times the return minus expected return squared. And we add those all up, we get the variance 88.71. And remember, if it asks for the standard deviation, it would be the square root of the 88.71. So nice little practice question in terms of calculating expected return based on a probability function, and variance and or standard deviation based on a probability distribution of stock returns. So now we're moving on to calculate the covariance given a joint probability function. Okay, so now because we're talking about covariance, we're talking about more than one asset. So in this case, we have company A and we have company B. So this is set up very similar to what we've just already seen. We have the probability, the industry is going to be good, it's going to be average, or it's going to be poor. But it's going to affect the two companies differently. So we want to calculate the covariance. So we can see, obviously, the probabilities are the same. 20% for good, 20% for good. 50% for average, it's got to be 50% for average, and 30% for poor, 30% for poor. So obviously the probabilities for the outlook for the industry are going to be the same, but the returns are going to be different. So for company A, 25% return if its industry is good, 12% if it's average, 10% if it's poor. For company B, it's different. You can see the numbers are lower. For the good industry, it's only 20%. Higher if it's average, 16%, and it's the same if it's poor. So what was the first thing that we did? Probability times the return is going to give us the 5%, 6%, 3. We're going to add it up. There's our 14% because we're using the same numbers. But now we're looking at company B. We're going to add it all up, and we're going to get to 15%. So step number 1 is calculate the expected return for A and calculate the expected return for B. This slide always looks confusing to candidates the first time, so we're going to talk our way through it slowly, and you're going to see that it's not too bad. So remember, we calculated the expected return of A as 14%, and we calculated the expected return for B of 15%. And there was two different scenarios for the economy. It was going to be good, it was going to be average, or it was going to be poor. And the probabilities for the good economy was 20%, and the probabilities for the average economy was 50%, and the probabilities for the poor economy was going to be 30%. And of course, 0.2 plus 0.5 plus 0.3 was going to equal our 100%, okay? So then what we did is we have our returns for company A on the rows, and we have our returns for company B on the columns, okay? So remember, if the economy was good, the return was going to be 25% to company A, and it was going to be 20% for company B, 20% probability. If the economy was going to be average, 0.5, the return for company A was going to be 12%, and the return for company B was going to be 16%. And if the economy was poor, then the return for company A was going to be 10%, and the return for company B was also going to be 10%. So that's how we set up our tables. In the middle, we had good, average, poor for terms of our probabilities. And then on the rows, we had the returns for company A, and on the columns, we had the returns for company B, okay? And so then to calculate the covariance, here's the formula given in algebra. It looks a little bit intimidating, but let's not worry about it too much. Let's just look at the solution. So the covariance is going to be the probability times return for A minus the expected return of A times return for B times minus the expected return for B, okay? So we can see that. Plus 0.5 times the return for A minus the expected return for A times the return for B minus the expected return for B plus 0.3, we're on this row now, times the return for A minus the expected return for A times return for B minus the expected return for B. So it's actually quite easily. So that's going to equal 11 minus 1 plus 6. So the covariance, given a joint probability function, the covariance between A and B equals 16. We're going to finish this LOS with a practice question. So the joint probability of returns for securities A and B are as follows. So remember here on the rows, we have the returns for security A, 25%, 60% probability, and a return of 20%, 40% probability. On our columns, we have the returns for security B, 30%, 60% probability, and a 40% probability of 20%. So this is a little bit easier than the example we saw on the previous slide because there's only two probabilities here, 60% and 40%, not three, so the math is a little bit easier. So the covariance of the returns between securities A and B is closest to A, 3, B, 12, or C, 24. Okay, we're going to work through the solution here. The answer is B. And you're going to see that with a bit of practice, this type of question is not too difficult at all. So first of all, we'll start with the formula for the covariance. It's going to be the sum of the probabilities times return A minus expected return A times return B minus expected return B. So we always break these questions into a number of steps. So what was step one? Step one, we have to calculate the expected returns. So the expected return for A is the probability 60% times 25% plus 40% times the 20%. And so that gives us 15% plus 8%. So we get 23%. So now we know the expected return of A is going to be 23%. Okay, we can plug that into our formulas. And we've got the returns, 25 and 20. So the expected return for B, same thing. It's going to be 60% times 30% plus 40% times the 20%. And that's going to give us 18% plus the 8%, 26. Now we have the expected return for B. That's going to be 26%. And we've got the returns for B. It's 30% and 20%. So we're just going to put in our formula then. It's 0.6% times return of A minus expected return of A times return of B, 30%, minus expected return of B, plus the 0.4, we're on the second row now, times return of A, 20%, minus expected return of A, 23, times return of B, 20%, minus the expected return, 26. So we run our way through our math, 0.6 times 2 times 4, plus 0.4 times negative 3 times negative 6, and that's going to equal negative 0.6 times 8 plus 0.4 times 18, 4.8 plus 7.2, that gives us 12. So you can see quite a few calculator keystrokes. Speed is a skill. Skill gets rewarded. Not too difficult. Step 1, calculate the expected returns. Step 2, set up your formula and plug in your numbers. Everything has been given to you except for the expected returns. That's the last LOS for this. That's the last slide for this LOS. Thank you very much.